In the first scenario, we search for two objects of unknown location using previously developed techniques. Given a set of navigable nodes seen on the left, a plan for searching the room is created. This diagram shows the two views selected for the first node visited. The first view is shown darker. Turning to face in the direction of the view, the robot acquires a camera image. The image is processed, producing a matrix of likelihoods for the presence of each object in turn. The best matches give rise to hypotheses for closer inspection. The camera magnifies each area of interest, and the process is repeated. The first object sought is the blue book in this image. Once the object hypothesis is large enough in the image, object recognition is performed. Upon finding a positive match, the robot calculates the distance and location of the object. Having exhausted the first planned view, the robot moves on to the second view associated with its current location. As it's already found one of the objects, it now searches only for the remaining one. The robot moves to the second node and its single view. Finding no hypothesis, it continues to the third node and its first view. The second object is the orange carton on the table. Finding it, it marks its location and terminates the search. In the second scenario, we let the previously obtained location of the object direct the initial search for it. A view is chosen to correspond to the direction from which the object was last detected. The carton is quickly localized and its position updated with a new estimate. In the third scenario, the robot reacquires the object in spite of occlusion. The same view is initially selected as in scenario 2. However, due to occlusion from a stack of books, the presence of the object cannot be ascertained. The robot then attempts a different vantage point. Unfortunately, this is still inadequate. Finally, it tries in the other direction. From here, the object is visible. In the fourth scenario, we show how the robot falls back to exhaustive search upon failing to detect the object in the expected location. Here, the orange carton has been removed to the desk. The robot again attempts an alternate viewing direction. Finally, discarding the old hypothesis, it creates a plan for exhaustive search as in scenario 1. Note that it's already covered the table and will not examine it again. The first node yielding nothing, the robot moves on to the second, which in this case has 4 views associated with it. In the second of these, it rediscovers the object. In the final scenario, we illustrate how the directed and undirected search modes are combined to utilize the robot's movements efficiently. Here, we again wish to find 2 objects, the position of only one of which is known. The robot starts by attempting to locate this latter object, here the orange carton. However, the other object happens to be in the same view. Exploiting this fact, the robot detects them both in parallel.